Hello. Welcome to our presentation for parents regarding the Into Math curriculum that we are launching this year at Platte River Academy. Thank you so much for taking some time out of your very busy life to tune in and learn a little bit about our math program and what our plans are for bringing this to kids. And hopefully you will get some of your questions answered through this presentation. I am Becky Bonner. I'm Director of Academics here at Platte River Academy, and I will be doing quite a bit of the talking and explaining through this presentation. And this person with me is Susan Shaw, and she's our ESL coordinator here at Platte River Academy, but more importantly, she is our math specialist, and we're so fortunate to have her because she has actually brought new math curriculum into schools and helped support teachers through that process many times before. So it's really good to have you.
And good to be here.
Susan's going to do a lot with the actual hands-on approaches. So we are ready to get going, and we are going to jump into just introducing that we have, beginning this school year, August 2022, our kindergarten through third grade students at Platte River Academy are using Houghton Mifflin Harcourt's 2020 edition of Into Math. Into Math is the name of the math curriculum. So this started this school year, but our decision occurred last year. And we have heard the question, why did PRA decide to change math curriculum? As you know, if you've been around, PRA has used Saxon for many, many years and continues to do so in grades 4 through 8. So why did we decide to move away from Saxon? One of the reasons, and there are many, one of the reasons was we began to see evidence within data that was revealing some weaknesses just in some abilities and some conceptual understanding that our kids were lacking. So that was a big piece of it. We also have a responsibility to make sure that we are offering standards aligned instruction, and Saxon, although it meets many of the standards, it wasn't precisely aligned. It is not precisely aligned to grade level standards for Colorado academic standards. And we have been following the academic standards for math, which do align with Common Core standards. Colorado, as a state, adopted Common Core standards back in 2010. And they've been revised a few times to Colorado specific. And we follow those. Those updates were last made in 2018. And so we do have a responsibility to align there. Saxon was last revised and updated in 2012. So that left a gap in time. Additionally, Saxon is no longer carried by a publisher. So materials were becoming increasingly challenging to obtain, and we were finding ourselves in a place where we were patching together curriculum for students. So it was time for a change, and we made a decision that we were moving into math. We selected it. We had a committee of parents, teachers, and our special education department was represented there, as well as high learning needs were represented on the committee. Susan Shaw was part of that committee work, and so was I. And so this panel of experts around math went through a thorough process to vet different curricula, and we narrowed it down to 3, from which we selected 1. So what criteria did we focus on? 1, in line with our curriculum and our mission statement, we were seeking a program that was content rich and well defined, also aligned with Colorado academic standards. Additionally, our data was showing us that number sense was a relative weakness, and so we wanted to make sure that the curriculum we selected offered very coherent instruction to establish a foundation of number sense. Additionally, we wanted to accomplish hitting those areas that we saw as weakness in the data that would lead to improvement, and that's around modeling, mathematical modeling, reasoning. These are particular performance aspects of demonstrating understanding of math, in addition to just getting kids to think on a critical level. So this particular slide, as I mentioned, our responsibility as a public school in the state of Colorado is to prepare students to interface with our academic standards. And Colorado's academic standards are from the Common Core set of standards for math. And as I mentioned, they've been revised a couple of times. This particular view that you're looking at right now is an actual report. It's an individual report that goes home with individual CMOS scores. This is a picture of a report of one of our students who was a fifth grader taking CMOS last year. And I bring this forward as just a sample of what we are looking at on a whole school level. So this is just one student, but it is very typical for what we're seeing, and it demonstrates that trend that we've observed. You see 4 content areas. You see 4 strands: major content, additional supporting content, additional and supporting content, and then you see expressing mathematical reasoning, and you see modeling and application. This view is actually representative of a typical Saxon student, and an actually very successful Saxon student. Major content, which is basic operations, being able to multiply, divide, work with fractions, decimals, all of it, very competent, does very well. This person probably does very, very well in math at Platte River, and this person is in the accelerated group in math. Also does well in that additional and supporting content, where it's problem solving. You might be graphing, you might be classifying geometric shapes, something like that, representing data. Still pretty strong. The blue line is this individual student. The light gray line that you see that runs parallel to the blue line, the light gray line is the district, Douglas County Schools as a whole, an average. And that dark black line is representing our state average. So this student is outperforming and looks quite strong. Now, when you go down below and you see expressing mathematical reasoning, this is where the Saxon curriculum doesn't expose kids. We don't practice this. It's not necessarily a piece of instruction. Kids' lack of exposure means they don't know how to interface with those particular items when they show up on the test. And likewise, the modeling and application. This is when they are being asked to represent and solve problems strategically and use and apply tools. Now, right this second, I don't have an example to give you, but we will be sharing information about what that looks like in a math classroom. But you can see from this data that we simply aren't preparing our children to be able to respond well to those items, and we have a responsibility to do that. This is what they're being asked to do, and this is just one point of measurement, but it's an example of what kids need to be ready to do when they're in math. So that's our data trend that we were referring to. So the intended outcome of this approach to math, into math, is that we end up with students who are confident and flexible thinkers, and they have an ability to apply both math and tech skills to a variety of problems. The problem is presented, and because they have this really high level thinking and this ability to think around and through numbers, they can apply the appropriate problem solving strategy to that. That they're able to creatively and productively collaborate with peers to solve problems. These are the things that we want them to be able to do, as well as effectively communicate their understanding of concepts. That expression of their reasoning, their ability to express that in writing or verbally, is a real need for that. So we actually are going to take a look at a video that is Conrad Wolfram. He's doing a TED Talk and he's speaking about the needs for future workers and where math plays into that. He's known for his work in technology, also in education reform, in really just finding ways to provide students with the skills they need to interface with math.
So let's zoom out a bit and ask, why are we teaching people math? What's the point of teaching people math? And in particular, why are we teaching them math? And in general, why is it such an important part of education as a sort of compulsory subject? Well, I think there are about 3 reasons. Technical jobs, so critical to the development of our economies. What I call everyday living. You know, to function in the world today, you've got to be pretty quantitative, much more so than a few years ago. You know, figuring out your mortgages, being skeptical of government statistics, those kinds of things. And thirdly, what I would call, you know, something like logical mind training, logical thinking. Over the years, we've put so much in society into being able to process and think logically. It's part of human society. It's very important to learn that. Math is a great way to do that. So let's ask another question. What is math? What do we mean when we say we're doing math or educating people to do math? Well, I think it's about 4 steps, roughly speaking. Starting with posing the right question. What is it that we want to ask? What is it we're trying to find out here? And this is the thing most screwed up in the outside world, beyond virtually any other part of doing math. People ask the wrong question, and surprisingly enough, they get the wrong answer, for that reason, if not for others. So the next thing is take that problem and turn it from a real-world problem into a sort of math problem. That's stage 2. Once you've done that, then there's the computation step. Turn it from that into some answer in a mathematical form. And of course, math's very powerful at doing that. And then finally, turn it back to the real world. Did it answer the question? And also verify it, crucial step. Now here's the crazy thing right now. In math education, we're spending about perhaps 80% of the time teaching people to do step 3 by hand. Yet that's the one step computers can do better than any human after years of practice. Instead, we ought to be using computers to do step 3 and using the students to spend much more effort on learning how to do steps 1, 2, and 4, conceptualizing problems, applying them, getting the teacher to run them through how to do that. See, crucial point here. Math is not equal to calculating. Math is a much broader subject than calculating. Now, it's understandable that this has all got intertwined. Over hundreds of years, there was only one way to do calculating. That was by hand. But in the last few decades, that has totally changed. We've had the biggest transformation of any ancient subject that I can ever imagine with computers. Calculating was typically the limiting step, and now often it isn't. So I think of in terms of the fact that math has been liberated from calculating. But that math liberation didn't get into education yet. See, I think of calculating in a sense as the machinery of math. It's the chore. It's the thing you'd like to avoid if you can, like to get a machine to do. It's a means to an end, not an end in itself.
So, as he spoke about that, the element of computation is secondary to solving problems. And Into Math rearranges those skills so that the understanding comes before fact fluency, but there's no mistake. Fact fluency is important. This is not an either or. This is a both and. They work together. Our students' understanding and ease within computation is a strength, and we want to make sure that that is maintained. At the same time, we want to make sure that kids have a strong visual and conceptual foundation of what they're doing before they just straight up memorize a fact. Sometimes they memorize and they don't really have meaning of what that looks like in another context. For example, they could memorize 3 times 2, but once it becomes more complicated, they no longer can visualize or conceptualize what's happening with those numbers, particularly when you introduce decimals or fractions. So fact fluency, we kind of compare to a student's memorization of sight words. Very, very important that they memorize what, is, was. Those are sight words that we want kids to have, recognize, and be able to read immediately off the page. But it doesn't change the need for them to have real phonemic awareness and understand that every letter makes a sound. And when we combine those sounds, they build words. So that when their sight words fail them, and they encounter a new word that they have to sound out, they have the tools to do that. So again, it's a both and. We want them to have that number sense and that flexibility to work around any problem and see numbers in that way, but also continue to practice those math facts. Both are important. This particular visual compares our approaches to math, whether we're using Saxon, and remember, our 4th through 8th graders are, well, 4th through 7th grade. 8th grade at Platte River does not use Saxon. They use a different textbook that is for pre-algebra and algebra. But 4th through 7th graders are still in Saxon textbooks this year. So K3 is into math, and then you move into Saxon. And this visual just kind of compares these two programs and these two approaches to learning math. On the left, you see a spiral staircase, and you are looking at it, spiraling and spiraling, and this represents Saxon. Saxon, incrementally and over a long time, an entire school year, maybe 2 years, it is spiraling and incrementally exposing students to different types of problems. There is no expectation of mastery the first time the child sees it, the second time, the third time. In fact, the child will see it, encounter it multiple times, maybe over the course of 2 years before full mastery is obtained. The spiral in Saxon goes below grade level and extends above grade level, so that when kids are working through Saxon, they might see something that really is not a grade level standard. It's above or beneath them. However, it's being spiraled around so that they are able to practice it again. And that spiral is what makes Saxon effective in students' learning. It's that repetition. On the right, however, you're looking at the New York City Library, and you see a very broad level. You see broad stairs and several banks of stairs leading up to 3 different doors. And I'm comparing this, or using this picture to look like into math, in that, let's say you were told you have an appointment in this building, either one, in room 312, which is on the 3rd floor. You're going to get to room 312 whether you take that spiral staircase or you approach that huge building with 3 doors. It doesn't matter which way you approach those stairs. It doesn't matter which door you enter on the right. You enter any way, you're going to be shown multiple pathways to the same solution. But you will eventually get to 312, and let's say 312 is 3rd grade math, and you are going to master it, whether you went round and round and round that spiral staircase over time to reach 3rd grade level, or you approach on a very broad level and were exposed over a broad range of time, multiple ways to experience, and entered one of those doors and then found the stairway up. You're still going to get there. It's different approaches. So we're going to see a video of someone explaining kind of this new math compared to more traditional. And in our context, we're talking about the comparisons of a program like Saxon versus a program like Into Math, and just how they approach is different. And we'll just claim it and say it is different. It is going to feel a little different, but that doesn't mean it's not working or it's not as effective. So Susan, would you kind of explain who this is that we're going to watch?
This video is by James Tanton. He's been one of my mentors for the past 10 or 15 years. He has his doctorate from Princeton in math education, or he's a mathematician, and his passion is bringing the joy of math to children and university students all the way up. He just wants everybody to have joyful math. James is from Australia. He has a pretty thick Australian accent, and in this video he's going to talk very fast. But I think if you hang in there, he seems to slow down a little bit, but he does a great job of explaining why we're not going to jump to an algorithm before we learn how to model and represent the math. So here's James.
G'day. There's a call across the US with the implementation of the Common Core state standards, and a call in parts of Canada too with our curriculum reforms, to go back to basics, to take mathematics learning for our kids back to what it should be, the mathematics we know and the mathematics we recognise. What we see going on in classrooms, at least with what our kids bring back home to us, seems strange to many, if not bizarre, if not absurd. The exemplar of absurdity making the internet rounds is this example, showing how to compute 32 take away 12 the old-fashioned way and how to compute it the new way. One can only look at this page and say, egad. I agree, 32 take away 12 is just 20 after all. We see the familiar traditional algorithm in this image. The image is a call to go back to the traditional ways, but we as adults have to be really clear as to what we want for our kids, what learning really means. The traditional algorithm certainly feels like learning to us because it's familiar. So let me talk about this example and what's really going on in our classrooms today. But let me work some numbers with a bit more meat to them. Let's do, say, 43 take away 27. Here's how my brain works. When I look at 43 take away 27, I think 3 and 10 and 3 to get the answer 16. Actually, I see this answer in my mind. I see a pair of rulers side by side. Put a 43-inch ruler and a 27-inch ruler next to each other, and we just see that their lengths differ by 3 inches and 10 inches and 3 inches. My brain naturally chunked the difference into 3 pieces, 3 and 10 and 3, the difference is 16. And maybe you can see how to do this one, 203 take away 125. Put 2 rulers side by side and see that 75 inches and 3 inches gets from 125 to 203. 203 take away 125 must be 75 and 3. That's 78. Whoa, this is clever problem solving. This is smart, clever thinking. However, I wasn't taught this mode of thinking in school. Back in my day, if I were asked as a youngster to compute 43 take away 27 in a worksheet, I was expected to write the following. This algorithm is very familiar to us adults, and it is hard for us to distance ourselves from it, to see how bizarre it really is at face value, because we're so familiar with it. Again, we often equate familiarity with understanding. Yes, of course we can unpack the algorithm and make sense of it, explain why we work from right to left, even though we're taught to read from left to right, and why changing 3 to 13 is valid if we also change the 4 to a 3, and why doing this carrying is helpful in the first place. But I see what's going on with rulers. I have to work to unpack with what's going on with the traditional algorithm. Another point. Is it even important for our children to do the traditional algorithm in this day and age? If the goal is to reliably get answers to subtraction problems, then the best and most appropriate means to achieve that goal is to pull out one's smartphone. We can't be teaching just for the sake of getting answers anymore. We must be teaching for thinking and understanding and developing the skills and confidence to just nudge your way through problems. So back to this image. Can you make sense of the image now, what the new way is doing? Of course, the author of this script chose an absurdly straightforward subtraction problem to begin with, and requiring a student to write out such absurdly detailed steps is, well, just absurd. But can you see the thinking in the new way nonetheless? I'd argue that it's harder to see the thinking, not just the procedural doing, in the old way. We adults really do fall into the trap of equating familiarity with understanding. We're teaching mathematics now with understanding. And by the way, students do still learn the traditional algorithm. It's now pushed much later in the curriculum, discussed only when firm understanding of what subtraction is and how it can be computed is fully explored. The traditional algorithm is then seen by one and all as a shortcut pen and paper method codifying all that understanding. And moreover, is offered only as one of many possible options for computing subtractions. After all, why on earth would I do 43 minus 27 via the algorithm when the answer is so visually obvious? Thanks.
So one of the things that has become more relevant in math education over the past 10 or 20 years is an understanding that children learn best through a concrete representation approach. That is what Into Math uses. And you may not understand it unless we take a look at it, and then you'll be like, oh, okay, now I understand what they're doing. At the very top slide on the right, what that represents is maybe a bowl of fruit. For our children, we might use something like linking cubes, and the children might have a handful of linking cubes that they're going to work with. And they'll use these in the beginning of lessons talking about number. Eventually, they're going to get tired of always having to use these big linking cubes, and they're going to want to draw pictures. And these are the representations we need them to maintain in their learning as they get to be good modelers in mathematics. Finally, they get tired of drawing the pictures, and then they just want to use what we call the abstract or the symbolic, and we move them into numbers. Then, once they've had a lot of practice with this, we'll move into the fact fluency. So we're not forgetting to do the fact fluency. We're going to put it at the end after we've built in that concrete, the representation, and then the abstract. Finally, we're going to keep pushing those math facts. We prefer to keep it in that order, not learning the facts, because we really want them to be able to model what they're learning. When you look at the slide, you can see how they have moved from the bowl of the fruit to representations, which is the drawing. This is called a bar model, and you will be encountering this with your children throughout the year. You may go, why do they have to do this? This is part of their learning process, and it helps them visualize the math. And then you can see how they get to the 3 plus 2 and making it 5. This transfers really, really well as we get into the higher level math. This transfers easily into decimals and then into fractions. So there's a process that we're building to. Sometimes it feels like with this math, where are we going? We give you a bag of jigsaw pieces to work through with your children, and you're like, what are you doing here? And so hopefully through this presentation, you begin to see where we are going with this curriculum. The next slide that we're going to talk about is the 10 frames. Probably if you're in kindergarten, you're working on 5 frames, and we're working on having children put cubes on these 5 frames and beginning to count 1, 2, 3, 4, 5, and each one has a box. As they get to the end of kindergarten, they're going to be working with the 10 frame and then building numbers up to 10. As they move into first grade, we're going to be moving the numbers from 10 to 20. But they should know by that, as they're getting into first grade, that I don't need to count every single block in that 10 frame. I just know that's 10. So it's just easier if I know it's 10 and I count up, or it's 10 and I take 1 away. An example of this is in this problem, 9 plus 6. I've heard that some parents go, what are they doing? Why are they having to use these 10 frames? What we want the children to do is internalize that they can move that 1 cube from the 10 frame on the right to the 10 frame on the left, and they know, oh, that's 10. So I know it's 10 plus 5 more, whether they count up 1, 2, 3, 4, 5, going 11, 12, 13, 14, 15, or they add the 10 plus 5. So that you see the transfer of how this goes and the value of visualization. We can memorize 9 plus 6, but that doesn't always transfer easily as we move into the bigger numbers, such as 79 plus 6, 79 plus 16, and then 70 plus 60. So as these numbers get bigger, the children will begin to visualize those 10 frames and see the process that they're trying to undergo. They will become much faster thinkers in their mental math if we use this. Later, it transfers into the decimals and then again into the fractions. That's why we're doing what we're doing.
So I know a question that many parents have is, how will my child's needs be met? How are we as a school meeting the varied needs of our learners? So Platte River Academy is going to continue to group students according to the skills within the grade level. So this is not new. We do it in math. We've always done it in math, where we have students grouped according to their readiness and their ability. And teachers will be adjusting their pacing, their approach, and the level of challenge they're supplying at any given time according to the students in their room and their readiness. So although both classes in third grade are going to be learning third grade math, one group, the challenge group, is going to move at a quicker pace, may not be doing the same lessons per se. They may be doing more challenge lessons and more activities in the classroom to go deeper into concepts rather than working ahead. Even though Saxon had kits 1, 2, and 3, and we did have students in second grade, for example, who were in kit 3, it's not necessarily third grade math. Remember that visual of that spiral staircase, and remember that items are given above grade level and below grade level, and they're spiraling within second grade. Sure, they were exposed to third grade learning. They were exposed sometimes to fourth grade concepts, but none of it was expected to be mastered at that level. So what you have to think about is that spiral is part of the Saxon move on, right? It's a continuous process that goes K through the upper grades. But we're going to continue to, through assessment and observation of kids in the classroom, we're going to continue to weigh their readiness and whether they need to be in a grade level approach where we're just going to do, one module at a time and proceed through the lessons as laid out in the curriculum, or if there is a group of kids who are ready for more and ready for that challenge. Please be assured that all children will receive instruction according to their ability within that grade level math to ensure prior year standards have been mastered. At this point, when you implement a new program, it's really important that we make sure we don't skip things and leave kids with gaps in their learning. So this is our grabbing it all year, and we're going to make sure that every kid has those foundational skills. Just know this. Always, the plan is to be able to carry these levels all the way through 8th grade, so a student who is ready for algebra or geometry will still have that opportunity to be there. Anything happening in kindergarten or first grade this year is not going to hinder that pathway.
So talking about what we are expecting through the curriculum and what we are going to be expecting from our PRA students, we want them to adopt a growth mindset. When we say growth mindset, that means they believe that they can. They believe that you believe that they can, and their teachers believe that they can. We want every child to believe in themselves in math. We will be developing strong number sense, and sometimes it may feel like they've already got this. We need to move on. We ask you to trust the teachers that they will know when your child is ready to move on. Demonstrate the ability, we want our children to be able to demonstrate the ability to visualize and represent, like I talked about with the 10 frames and drawing and representations. We want them to understand what's going on in a math problem. We also want them to begin discussing how they think about mathematics and developing their reasoning and justifying their thinking.
And those are the pieces, those last two bullets in particular are the pieces that our data revealed are relative weaknesses. So that is a really big piece of this programming.
So many of you have heard we will be challenging your children. And we wanted to kind of give you an example of what does a challenging task look like. So let's talk about first grader Tommy. He often finishes his work first. He memorizes things super easy. He races through his work, and he's got some mistakes in there generally. And he might say, well, my mind just knew what I did, just knew this. I just got it. So what a teacher might do for a student like Tommy is we might come along with a pile of cubes and we might read to them a problem. So the problem would be something like, there are 10 eggs and 3 baskets. The brown basket has 1 more egg than the red basket. The green basket has 3 more eggs than the red basket. How many eggs are in each basket? I might drop a bunch of cubes in front of Tommy and walk away and let him struggle and develop his perseverance. Whether he uses the cubes or not is really irrelevant, but 9 times out of 10, they're going to start reaching for those cubes because it helps to touch them. That's what we mean when we're saying a challenging task, where we're taking a child deeper, not necessarily faster. We're building on that mathematical reasoning. I hope this example helps you understand what we mean when we say going deeper.
So how about that homework, which I know you all are encountering now, and perhaps that is the very topic you tuned into this to learn more about. So let's talk about homework. What if the homework seems too easy? You're seeing your child get involved, or the problems in front of your child seem so very simple. You might be thinking, oh my goodness, they were doing this last year or the year before. This math, 10 plus 3 on the page, for example, is way too simple. First, at this point, we're teaching the students a whole new language, and we're teaching them independence, and we're teaching them to show pride in their work, and really to start to express and make sure that they're including those other details and they know how to represent the problem. You might notice that a lot of the tasks in homework are asking kids to represent or model, and so that becomes the work that they're doing. Explain to your child that although the math seems simple, there's probably other things that they need to be working on. You could celebrate that it's simple for them. That's great. You're not working on that. But tell me, I want you to explain to me, or maybe show me with these blocks or cotton balls or whatever you have at the house that you're going to put in front of them. Explain to me what you're doing there and how you know your answer is right. Work on that communication piece and ask them if there's another way to do it. Sometimes when we memorize a fact straight up, and granted, there's only so many ways that you can approach this, but once we memorize a fact, is there any other way to do it? We want to stretch their thinking to really imagine that there are other ways to approach it. On the reverse side, what if this homework is too hard? It's consuming too much time. It's causing frustration, maybe for you, for your kid, for both. And it's going on, and it seems like you're not really sure what you're supposed to be doing. We ask that you try. We ask that you guide the child to encounter the problem and you read it to them and you try to get them to remember what was happening in the classroom and what did your teacher say and how did you do this in class. If it's just not working, 15 minutes, 30 tops. The child is frustrated. You read that situation, circle it, write a note to the teacher, just say, we had to tap out. This one, we just didn't get it. I know some of the teachers are providing answers, and very soon we will be prepared to release some online resources that may prove to be useful at home for extra support while you're doing homework, just to help you understand what the intent is or what the approach was in the classroom. You will be seeing communication coming home about these resources, and so hopefully that will be helpful to you. In the meantime, ask your kid to do their best. If it's not working, circle it, move on. We sent home a packet of homework tips a couple of weeks ago, and I just want to highlight some of the big ideas there. First of all, if your child is one that can zip through this pretty independently and confidently, celebrate that. You are awesome. You seem to know what you're doing. That homework should be independent to the greatest extent possible. So let's be happy that that's the case if it's not consuming a ton of time. It's also helpful for your teacher to know that. If it seems too easy, it's taking hardly any time at all, a note to your teacher might hint to them to just fold in a little extra challenge so there's a little more to it. Allow your child to figure things out on their own. If they are stumbling a little, like Susan said when she put these blocks out, walk away and let them think and scratch it out a little. That's where growth mindset comes from. You can do hard things. Not everything comes easily to you. Memorizing and getting a right answer isn't the end goal, right? There's more to it than that. So let them push through a little bit or ask questions of you. Encourage your child to share kind of what was done in the classroom, what their teacher says. Maybe pretend to be the teacher. What does your teacher say when she shows this? And we ask that you speak positively to your child about math, about your child's teacher, about school, about this transition. It's hard for everybody. Different is tough. We're in that transition time and it doesn't feel comfortable. And one of our inclinations as human beings is to kind of push back against change. We liked the way it was. It was simple. I understood it. You will understand this too. You got to just give it a little time. Take note of the time. Like I said, if it's taking too long or we're reaching frustration, please do not continue. Circle it, note to teacher, it's all good. It's all good. We're all learning right now, and the teacher will adjust accordingly. So don't worry about that. So as we look forward beyond this school year, where are we headed into math? So this is showing our implementation plan for moving into the future. So this year, as we've talked about, it's kindergarten through third grade only. 4th through 7th grade continue in Saxon as they were. This year is a curriculum review with an intent to select a new curriculum for 6th through 8th grade. Into math will go through 5th grade as the students become older. So this year, this is it, K3, and we'll be looking for a 6-8 curriculum. The following year, 23-24 school year, kindergarten through 4th grade, so as this group of 3rd graders goes to 4th grade, they will be into math. And 5th through 8th will begin to supplement either from into math or from the newly selected program. They're going to supplement and pilot elements of that program so that kids are being exposed real time. We are not going to wait. We want to be sensitive to the needs of each kid, and we want to be sensitive to this transition process. We do not want to do it all at once. We've kind of heard from other schools who implemented in that fashion. Didn't go well. It's not best for our students. So, but we don't want to not expose our kids to those items and experiences that we know they need. The following year, 24-25, kindergarten through 5th grade will fully be integrated into math, and 6th through 8th grade will begin their new program, which will be announced this spring. So in 3 years, by the time 3 years has gone by, Saxon will not be part of Platte River Academy anymore. So if you still have questions, and you very likely do, we are absolutely here to support you and your child through this transition. So if you have a question about lessons, a particular lesson, an assignment that's bogging you down, or something that a particular vocabulary, something that keeps coming up relative to classroom assignments, or maybe an assessment that you see come home in the Thursday folder, homework questions, please just email your teacher. Either email with that specific question or email and request a time to talk with them. They would be very happy to talk to you about your questions. Remember, Parent-Teacher Conferences is coming up in October, so make sure you sign up. Obviously, 15 minutes isn't long enough to get a bunch of these questions answered, so keep that in mind. If you have Into Math program questions in general, you want to know kind of what's going on, what the approach means. You need some more information about the cubes and kind of how it all works together. There is a special email that we've just built that is intomath@praka.org. submit there, and someone on this team right here, either Susan or myself or another teacher that's involved in this implementation, will answer your question. When we do roll out on online resources, and again, that's not quite available yet, but when that is available, you'll know, you'll get a letter. It will be really clear that we're starting with that. Please submit any tech assistance requests to our help desk at PRA. And finally, if you have questions about this implementation cycle or how we're selecting curriculum, or you want to know more about how future years are going to integrate these different approaches to math, please just directly email me and we can either sit down together and talk about it, or if it's a question that I can answer in email, I sure will. So hopefully through the course of this video, you were able to get a little more information about Into Math that helps you understand how this curriculum was selected and where we are, how this approach varies and is different from Saxon Math, and where we're headed. We are continuously along the way going to be assessing how our children are doing with this curriculum, how they are interacting with the lessons. Teachers are also learning this, so it is a real-time kind of experiment, to be honest. But there's a lot of ways that we can collect data and information from students in the classroom, which teachers are doing right now. Making decisions about how fast can I go, how much deeper can I go, are they ready for challenge, and how are we going to move forward from here. So those decisions are being made real time. Please trust that we are not going to leave anybody behind. We're all going to get through this. It seems really challenging right now, but the more we become familiar with the language and the way the lessons are presented, I think everybody is going to feel more comfortable. So we got to just sit in it, take it, ask questions if you have them, and be patient with the process. Thank you so much for tuning in.
Thank you.